I thought number 2 on section 7.5 might be a good one to discuss. I don't think I'm going to do the whole thing, but I'm at least going to go through the setup here. This one's kind of interesting because this is not something moving in a circle. This is not something moving in a wave pattern, and yet it can still be modeled using a sinusoidal function. So we've got this girl on a swing, and they're representing positive 17 here as when she's over the water, and negative 23 here is the number of feet behind the water she is. So she goes as far as 23 feet behind the shore, as far as 17 feet past the shore, and she's swinging back and forth. And the key here is it's repeating. So we say this is periodic motion, all right? So the big idea here is, notice the input here. We want to put in a time, and we want to get out her location. Is she over the river? Is she behind the river? That sort of thing. So what we're really doing is we're stretching and compressing a trig function. We're not putting in a degree measure. We're not putting in a radian measure in the typical sense. But we're going to stretch the sine function so it will match up with that kind of data. Okay, so yeah, our calculator is still going to be in radian mode when we're typing everything in and all of that, but the input variable here is really going to represent a time. All right, so the big thing that we hammered prior to this section was really getting a good understanding of graphs, and if you have that, it makes these setups really easy. Just get a couple of points and make a sketch. So we know at t equals 2, she's at negative 23, so I'm going to plot that point here on my graph. We're starting out down here. When t is equal to 5, y is equal to 17. And that's going to be this point right here. And so anyway, you should be able to basically kind of draw a curve through here. They told you this is going to be a sinusoidal relationship, I believe, or at least we're going to have to assume it is. And so we're getting a curve that looks maybe something kind of like that. Okay, so a couple of things here. Should be able to figure out the amplitude and the midline and the period and the phase shift relatively easily with what we have. All right, the amplitude. This thing goes from negative 23 to positive 17. That's a total distance of 40, okay? Remember, the amplitude is halfway between the top and the bottom, so half of 40 is going to give us an amplitude of 20. All right, the midline is halfway between these two, so you could count down 20 from 17. I usually average the two values. If you add 17 and negative 23 and you divide by 2, you get negative 3. So the midline is going to be, shifting this graph down 3, it's going to be at y equals negative 3. All right, the period of this graph. Now, you have to be careful here. If you think about what a sine or a cosine function looks like, let's just look at a sine function here for a second. A sine function is doing this sort of thing, okay? You can break a sine function up into 4 parts. You've got the part where it goes up to its max, you've got the part where it goes back down to the midline, part where it goes down to a minimum, and the part back up to the midline, okay? Notice if you go from the max to the min, that's only 2/4, that's only half of the cycle, okay? So we're going from a minimum to a maximum here. That's only half the cycle. So from 2 to 5, which is a total of 3, is half the period. That means the period is 6, okay? Also remember, the period does not show up in your equation. You've got to use the little period equals either 360 over b or 2 pi over b. I'd like you to do all these problems in radians. These application problems are almost always done using radian settings. So the period is equal to 2 pi over b is the formula we're going to use here. Okay, so I would like the period to be 6, and that's equal to 2 pi. I got to figure out what do I divide 2 pi by to get 6. So multiply both sides by b. We've got 6b is equal to 2 pi. Divide both sides by 6, and we find out that b is equal to pi over 3. So remember, you're going to have a pi in that b value. If you want to cancel out the pi from the radians set up in these problems to have something that's like whole number minutes, there's going to have to be a pi in it. So it ends up being a multiplier of pi over 3, okay? Which is interesting, by the way. Notice pi over 3 is just a little bit over 1. Okay, the normal period of a sine or cosine function is 2 pi, which is about 6.28. We just want the period to be 6. So we're actually not changing the period very much with that pi over 3, as strange as it's going to look. So the period is 6. That's going to result in a b value of pi over 3, okay? The final thing here, for the phase shift, we need to decide if we're using a sine or cosine function. Remember, the sine function starts out at the midline and goes through a cycle. We don't actually know that the midline is cutting, you know, somewhere through here. We don't actually know where it hits the midline, okay? You don't want to guess. I don't think it's actually going to go through the origin. That's a dangerous assumption to make. You could argue, you know, if it's half a cycle from 2 to 5 between a 3-unit horizontal change, you could do a 1.5 unit change, and I guess 3.5 is where that point would end up being. But actually, it's not along the axis. 3.5 is where it would be along the midline. And so you could go back 1.5, and that would tell you it hits the midline at 0.5. But anyway, that's complicated. The point is, if you have a max or a minimum, use a cosine function, okay? A cosine function starts out at the max. It does that sort of thing, okay? And so you can just say, look, they took this cosine function, and you could either use a negative cosine function and say they shifted it over 2 units, but I would just use the positive version and say it's been shifted over 5. So I'm going to use a 5 to the right phase shift. I'm going to use a cosine function. So let's put this whole thing together. All right, the amplitude is 20, so we've got, does it tell us what to call this? Y equals 20 cosine. Remember, my multiplier is pi over 3. That should be out in front of parentheses for the phase shift, okay? My phase shift is 5 to the right, which means I'm going to have an x minus 5, and then we're shifting the whole thing down 3 because of the midline, and that's my function, all right? Now, they're going to ask you a bunch of other things, okay? So they're going to ask you, for example, to find y when x is 3.2. You'll just drop 3.2 in that equation. Make sure you're in radian mode to do that. Remember, when you put this into a calculator, you're taking the cosine of this whole thing. And in fact, you may want to put that pi over 3 in its own set of parentheses as well. So all of that should be inside your cosine function, or you'll get an answer that doesn't make any sense. All right? So anyway, I'll let you take care of that, and I'll let you think about the other parts of the problem. Now, before you do any calculations, make sure you run this. Make sure things are working. Number one, make sure you're in radian mode because we use 2 pi to find the periods. So I'm checking my mode here. We're in radians. We're good. Okay, I'm going to go up to y equals button. I've subbed it in. Notice I've got parentheses. I've got the pi over 3 in front of the x minus 5. Okay, and then I close out parentheses for all of that, then I have the minus 3. So you got to be very careful when you type it in. If you run a table, you can start it out at 0, count by 1s. Check and make sure it's got the key points. It's supposed to have the 0.2 negative 23. It's supposed to have the 0.5 17. You may also want to graph it. Remember, if you graph it, make sure that you're picking a scale that matches up with the x and y scale that you've got in the picture. So for this particular graph, when I set up the window on my calculator, I'll have the x go maybe from like 0 to 10. I'll have it go a little beyond this. So 0 to 10 on the x min and max. Y I'm going to have go from maybe negative 25 or negative 30 to about 20. I'll go a little bit above and below. And then when we graph it, you can see that looks a whole lot like what it is. And you can trace on it too. If you hit the trace button, you can kind of see that you're close to some of the key points that you were supposed to have. So again, make sure you have the right function. Don't use the wrong function for all the application parts of the problem. Make sure you check it first.